Hello everyone. In this presentation, we will explore how statistical dispersion measures help us understand student feedback data more effectively. When we analyze teaching quality, lab facilities, or peer collaboration, it's not enough to just look at averages. We need to understand how spread out the responses truly are. So let's walk through why dispersion matters and what tools we can use to measure it. In large educational systems, thousands of students share feedback across many categories. This creates a huge amount of data. Our challenge is to figure out how this feedback varies. Is everyone having a similar experience or are there major differences? Understanding the spread of the data helps institutions make better decisions and improves the overall quality of education. Now, why dispersion matters? There are three big reasons dispersion is important for. Number one, consistency detection. If dispersion is low, it usually means students share the same experience. High dispersion means inconsistency which needs attention. Number two, outlier identification. Sometimes a few ratings are extremely high or low. Dispersion helps us spot these unusual points that might highlight exceptional teaching or problem areas. Number three, data quality assessment. When feedback is too scattered, it might not be reliable. Understanding the spread helps ensure that decisions are based on meaningful patterns, not just noise. Now, there are in total three essential dispersion measures. There are many ways to measure dispersion, but there are three most useful ones for educational analytics. They are number one, variance, then interquartile range, denoted by IQR, and coefficient of variation, denoted by CV. Each one tells a different story about the data, so we'll break them down one by one. Now, number one, variance. Variance is the measure of how far each individual score is from the average. But instead of just looking at differences, it squares them. This gives more weight to larger deviations. Now, high variance means students had very different experiences, and low variance indicates the more consistency. For example, if teaching quality has a sudden spike in variance, it might mean the teaching style is controversial or student preparedness levels vary widely. Now, number two, interquartile range, denoted by IQR. IQR focuses on the middle 50% of the data, from the first quartile, Q1, to the third quartile, Q3. This makes it less sensitive to extreme values. It's very useful when analyzing lab facilities or feedback where a few students might give extreme ratings. IQR helps us understand the typical experience while filtering out extreme outliers. Number three, the coefficient of variation gives us the relative spread in percentage form. It's calculated as CV equals to standard deviation upon mean whole into 100. Now, what's the best part? CV allows us to compare data sets that use different scales. For example, if teaching quality is rated on 1 to 10 scale and peer collaboration on a scale of 1 to 100, CV helps us compare how variable each metric is, even though the scales are completely different. Now, let's talk about how we can compute these measures efficiently, especially when dealing with millions of records. Number one, SQL aggregate functions. Functions like var pop and stddev let, let us compute variance and standard deviation quickly within the database. Strategic indexing. Creating indexes on key columns like student ID or course ID can drastically reduce computation time. Distributed processing on Spark or Hadoop. For huge data sets, distributed systems process calculations across multiple nodes faster and more scalable. Vectorize operations in Python. Using NumPy and Pandas, we can compute metrics on entire columns at once, avoiding slow loop based operations. This slide compares the performance of different strategies based on speed and scalability. Distributed systems perform best for massive datasets. SQL works extremely well for medium sized datasets. Python vectorized approaches are ideal for the data scientists working locally. Choosing the right method depends on data size and available infrastructure. Now let's talk about the key takeaways. To wrap up, variance, IQR, and CV each reveal different aspects of data variation. They help ensure feedback analysis is accurate, reliable, and meaningful. Modern tools from SQL to Spark make large-scale computation efficient. The best method depends on data characteristics like scale, outliers, and volume. Understanding dispersion isn't just about statistics; it's about improving the educational experience through better insights. Thank you for listening. I hope this made the concept of dispersion easier to understand and showed you how powerful it can be when working with student feedback analytics. I hope you enjoyed. Thank you.